Hi everyone, welcome back to the channel. Today we are going to learn one of the most important sorting algorithm, that is selection sort. The algorithm is extremely popular in interviews and is also very easy to understand. So in this video we will understand what selection sort is, how it works step by steps, then we'll understand the algorithm, then we'll do the Java implementation for the same. So let's understand first what is selection sort. Selection sort is a simple comparison based sorting algorithm and it works how selecting the smallest element from the unsorted portion and placing it at the correct position of the sorted portion. So basically what we will do, we'll convert the array into two parts. One is sorted part, another will be unsorted part. If you remember in the insertion sort, what we did actually, we keep the first element as a sorted part, then the remaining element as a unsorted part. But in selection sort, this is little bit different. Like the sorted part will be initially empty and the unsorted part will be initially the whole array. And for each iteration, what we will do, the smallest element from the unsorted part will be selected. After selecting the smallest element, we'll place it at the end of the sorted part. So this will continue until the array becomes the sorted. So this is how it works. If we understand this, it follows the principle. We'll select one element, then we'll compare it, then we'll swap it, then we'll repeat it. So this is the algorithm logic we will apply in each step. Let's understand this by taking an example. Suppose I have a array which is 8, 5, 3, 2 and 1. So if this is the 0th index and this is the nth index, right? So in the pass one, what I'll do, pass one means the number of iteration. So I'll iterate over each element and I'll find the minimum element, right? So here the minimum element is 1. So after finding the minimum element, what I'll do, I'll swap this 1 with the 8. So now my array will look like something 1, 5, 3, 2, 8. So if you see now, this one is sorted and this one is unsorted. In the next pass 2, same thing I'll do. I'll find the minimum element from the unsorted array. So which is a 2, right? So minimum element is 2. Now what I'll do? I'll swap 2 with 5. 1, 2, 3, 5, 8. Okay. Now 1, 2 is sorted and 3, 5, 8 is unsorted one. Again in the pass 3, the same thing I'll repeat. Here the minimum element is 3, but we don't have to sort it anyway, right? Because it is already in the correct position itself only. So 1, 2, 3, 5, 8. So this is now sorted and this is unsorted. Again I'll go for the pass 4. So again here the minimum element is 5, right? So min element is 5. My array will look like this. It is in the correct position, so no need to swap it again. So now this is my sorted part and this is my unsorted part. So it will be uh, automatically sorted because it has only one element, right? So there is no need of further iteration of this one. So if my elements are 5, then I need to go for iteration of nth minus 1. Okay, so let's write for the algorithm logic for this one. So I'll go for the loop from 0 to n minus 1. Okay, then what we did, we find the minimum element, right? So but we are not sure which is the minimum element. So what we will do, we'll take the first element from the unsorted array as a minimum element. So we'll assign the minimum element as a index as a first itself only. So after finding this out, what we will do, again we will run another inner loop. Inner loop is for that we need to find the minimum element. So this is for the passes. Okay, and the inner loop is for to find the minimum element, right, and to update the exact minimum index in the main. So from here what we will do, Here I'll start the j from I plus 1 to, so I plus 1 to the nth index. Okay, so after finding this, if we have to check, we have to put one if condition to find the minimum element. If array of j is greater than min, or sorry, the less than minimum index. Okay, so the less than of minimum index, array of minimum index. So what we need to do? We need to swap the minimum index, right? We need to store the actual minimum index. So the mean will be j. So here in this logic, we found out the mean element. Okay, after finding the mean element, what we will do? This is the loop ending. Okay, so we found the mean element. Then after finding it, what we will do? We'll swap it. So after swapping, so here we'll place the swap logic. So swap, where we will do? So this minimum element will be swapped with the first unsorted element. So it will be swapped the min element with the first element of unsorted subarray. So this is exactly what we need to do. So this is the algorithm. We need to run the loop from 0 to n minus 1 for the number of passes. So if you see, we have 4 passes over here. So then we will assign the minimum index as a first index because we are not sure which index is the minimum one. Then for j, this is the inner loop to find the minimum element. After finding the minimum element, what we will do? We will swap the minimum element with the first element of the unsorted subarray. So in this way, we will sort it using the selection sort. Let's understand this in the Java example. So if you could see my screen, that I have created a class named as a selection sort. So we'll do the same thing. First we need a main method, and after the main method we need an array of elements, right? So integer array, I'll keep the name as array itself only. Then we'll keep the elements same, 8, 3, 5, 2, 9. Then we need to print the element before sorting and after sorting, so that we could see the differences. Okay, so to print the elements we need one loop. It is a num, then we'll iterate over the array to print the each element. Num, then we'll keep one space in between of each element. Same thing we'll do for the, here I'll keep the selection sort logic, we'll put it there. Okay, so this is after sorting, and here one thing I'll do, I'll keep one extra line to make print that after sorting in this next line. Okay, now we have not provided any selection sort logic. If we could run this, you will see no differences in between. Okay, so before jumping into the logic, whatever the algorithm logic for the selection sort, we need two loops. Okay, like for the bubble sort and the insertion sort also, we need two loops, one outer loop, then one inner loop. So the inner loop will find the smallest element from the unsorted part. Okay, and the outer loop selects the position where the smallest element should go. So the inner element will find the smallest element from the unsorted part. Then the outer loop will find the position where the element should go. Okay, so this is for the outer loop. We'll start from 0th element and it will go till the end -1, then I plus plus will increment it by 1. Okay, then we are not sure which is the minimum element, right? So for this one, we'll keep the ith index as the minimum index. Then we will assign the index when we find the exact minimum element. Then we need an inner loop for integer a equal to I plus 1 I array dot length, then j plus plus. So we need to find the minimum element, right? So we write it if the array of j is less than array of minimum index element, because the min here we are not storing the element, we are storing the index value, right? Array of min. So in that case we are just assigning the index to the minimum index. Okay, min equal to j. So this logic, exactly this inner loop, this for loop will find the minimum index. Okay, after this, once we find the minimum index, we will swap it into the correct position. Integer 10, then array of min, then array of min will be swapped to array of I, right? So equal to 10. So that's it we have to do. Now if we could run this, okay, sorry, here I have done the mistake. That's why, because here I have given the I, right? Now I could see that our array is sorted, right? It's 2, 3, 5, 8, 9. So what we exactly did over here, we repeatedly find the smallest element and swap it in the correct position. So if you come to the time complexity, then the best case will be O of n square, average also same, and the worst case also same. So why this is O of n square always? Because the selection sort always scans the full array, even if it's already sorted. Well, the only difference between the bubble sort and selection sort is that it uses fewer swap. Once only it will find the minimum index, then only it is doing the swapping. So that's the only differences. Okay, so that's all for the selection chart. Thank you.